If you're still crafting the perfect prompt to get better AI results, you might be missing the bigger picture. Leaders like Shopify's CEO Toby Luck have publicly shifted to something called context engineering, describing it as the art of providing all the context for the task to be plausibly solved by the LLM. While everyone else is obsessing over prompt tricks that worked 6 months ago, context engineers are getting consistently better results by focusing on something entirely different. Today we're breaking down why this shift is happening, what context engineering actually means, and why it might be the most important AI skill you can develop right now. Stick around to see how teams are transforming their AI workflows by swapping prompts for context. But first, let's examine what happened to all those prompt tricks that used to work so well. Your context engineering future. Building these capabilities requires specific technical skills that mirror information architecture and systematic thinking rather than creative writing. Context engineers need to identify relevant information sources, organize data hierarchically, and understand how different pieces of information relate to each other. This involves developing skills in knowledge management, documentation standards, and information synthesis that LangChain emphasizes for packaging information effectively. The mindset shift requires moving from trying to manipulate AI responses to providing comprehensive information packages that enable better decision-making, particularly as Anthropic notes that agents often engage in conversations spanning hundreds of turns, requiring careful context management strategies. Individual practitioners gain competitive advantages through context engineering skills that scale across different AI models and use cases. While prompt engineering tricks become obsolete with each model update, context engineering skills improve over time as models become more capable of processing complex information. Freelancers and consultants who master context assembly techniques can deliver more consistent results to clients. Knowledge workers who understand context engineering principles can leverage AI tools more effectively across different projects and domains. Enterprise teams see dramatic improvements when they adopt context engineering approaches systematically. Companies that implement context engineering frameworks report higher consistency in AI outputs across different team members and projects. Organizations are already forming specialized roles like context architects and investing in systematic frameworks, as seen in approaches documented by LangChain and Cognition. The career opportunities span from these specialized positions to broader applications across existing roles in data analysis, project management, and strategic planning. Businesses should restructure their AI strategies around context engineering principles by establishing information architecture standards, creating reusable context templates, and training teams on systematic information assembly. This involves auditing existing knowledge management systems to identify gaps in accessible information, developing processes for maintaining context packages over time, and creating quality control mechanisms for context validation. Companies need to shift budget allocation from prompt engineering training to context management infrastructure and tools. Teams track context, completeness, and output consistency, rather than relying on complex optimization approaches. Advanced practitioners focus on measuring how different context packages perform across similar tasks, analyzing which types of information contribute most to successful task completion, and developing feedback loops that improve context quality over time. This mirrors the quality control processes that LangChain describes for maintaining effective context packages. Early adopters of context engineering are seeing dramatically better AI results than their competitors because they provide models with the information needed for accurate task completion. These organizations report higher consistency in AI outputs, reduced need for manual corrections, and better scalability across different use cases. The competitive advantage comes from building sustainable AI interaction systems that improve as models advance rather than depending on techniques that become obsolete. The timeline for context engineering becoming the dominant approach aligns with industry predictions, suggesting standardization within 12 to 18 months, as organizations recognize the limitations of prompt-based approaches. This shift represents a fundamental change in how we think about working with AI systems. Context assembly in the real world. Companies implementing context engineering follow systematic approaches that mirror how skilled researchers build case files. A marketing agency abandoned their elaborate prompt templates after months of inconsistent results across client campaigns. Their breakthrough came when they created what Lance Martin describes as context packages, comprehensive folders containing brand guidelines, previous campaign materials, target audience research, competitor analysis, and performance data from past projects. When creating new content, team members simply upload the relevant context package and ask straightforward questions like, "What's the best approach for this campaign?" The results became immediately more consistent and higher quality than anything they achieved with elaborate prompting techniques. Professional context engineers approach information gathering by identifying all stakeholders who might have relevant knowledge, then systematically collecting documents, data, and background information. The process involves creating detailed inventories of available resources, categorizing information by relevance and recency, and organizing everything into logical hierarchies that models can process effectively. This mirrors the cognition team's approach to solving multi-agent workflow problems. They found that maintaining context continuity through single-threaded linear agents prevented the miscommunications that plagued systems where context got transmitted between multiple agents and sub-agents. Building comprehensive context packages requires different approaches for different task types. Software development contexts include code-based documentation, architectural diagrams, previous bug reports, and coding standards. Content creation contexts contain brand guidelines, audience research, competitive analysis, and performance metrics from similar projects. Financial analysis contexts incorporate historical data, market research, regulatory requirements, and relevant industry benchmarks. Each package type follows established templates but gets customized based on specific project requirements and available information sources. Emerging platforms now support context compression and storage capabilities that help teams manage their information workflows. These tools integrate with existing business software to automatically pull relevant information from CRM systems, project management platforms, and knowledge bases. Organizations establish context libraries where successful packages get stored and shared across teams. Quality control processes ensure that context packages meet established standards before deployment. Context engineering scales across organizations through standardized processes and reusable components. Teams create template contexts for common business scenarios, then customize them for specific projects. Training programs teach employees how to identify relevant information and assemble it effectively. This systematic approach works across departments and projects in ways that individual prompt engineering skills cannot. Multi-step workflows benefit significantly from context engineering approaches. Complex projects that span multiple phases maintain context continuity as work progresses. Teams can add new information to existing context packages rather than starting fresh with each phase. Dependencies between different workflow stages get documented and preserved, eliminating the information loss that typically occurs when projects move between team members or phases. This foundation enables organizations to build more sophisticated AI applications that can handle increasingly complex business requirements. The architecture of smart AI systems. Smart AI systems require architectural foundations that prioritize information management over prompt optimization. As Cognition notes, context engineering is effectively the #1 job of engineers building AI agents. This shift reflects the practical reality that production AI systems must handle complex tasks and maintain consistency over extended periods, something that clever questioning strategies simply cannot deliver. Multi-agent AI systems face fundamental problems that prompt engineering cannot solve. When multiple AI agents work together on complex tasks, they must transmit context between each other without losing critical information. The Cognition team discovered this challenge while building a Flappy Bird clone, where miscommunications between sub-agents led to one building a Mario-style background while another delivered a non-functional bird. Context engineering solves this by ensuring continuous context flow throughout the entire system, preventing these costly misinterpretations by maintaining comprehensive information packages that every agent can access. The technical architecture of context-aware AI systems centers on maintaining information coherence across complex workflows. These systems employ specialized context compression techniques that distill conversations and actions into key moments and decisions. This compressed context then informs subsequent subtasks without overwhelming the system's processing capacity. Context-aware systems use sophisticated management layers that handle information flow across different components and agents. Context compression and management techniques enable AI systems to handle increasingly complex tasks by preventing context windows from overflowing. Modern systems implement 3 core strategies for context management that Lance Martin identifies as essential patterns. Curating context involves managing the tokens an agent sees at each turn, ensuring the model receives the most relevant information. Persisting context involves systems to store, save, and retrieve context over time, allowing the agent to build upon previous interactions. Isolating context involves approaches to partition context across agents or environments, preventing interference and maintaining focus. Long conversations and complex workflows require careful context management strategies. Anthropic observes that agents often engage in conversations spanning hundreds of turns, requiring careful context management strategies. This careful management ensures that AI systems remain on track and provide accurate responses throughout extended interactions. Context engineering maintains coherence across these lengthy workflows, where prompt-based approaches typically fail. Context system design follows emerging patterns, focused on curating, persisting, and isolating context to build reliable and scalable AI systems. These patterns address scalability challenges that prompt engineering cannot solve, as AI applications evolve from single prompts to complex dynamic agentic systems. Context engineering enables the creation of systems that handle increasing amounts of information and complexity. When an agent performs unreliably, practitioners commonly observe that the underlying cause often involves inadequate context, instructions, or tools communicated to the model. Context engineering ensures that language models receive comprehensive information packages that enable accurate task completion. This represents the maturation of AI tooling from experimental to production-ready systems. The question becomes what specific skills and approaches professionals need to master this emerging discipline. What context engineering actually means? Context engineering represents a systematic approach to information management that mirrors how humans actually work with complex problems. Think about the last time you asked a colleague for advice on a complex project. You didn't just ask, "What should I do?" You provided background context. You explained the constraints, shared relevant documents, described the stakeholders involved, and outlined what you'd already tried. Your colleague needed all that information to give you useful guidance. Context engineering works exactly the same way with AI models. As Andrej Karpathy describes it, context engineering is packaging and managing the context needed for a task, much like an operating system curates RAM. Instead of spending time crafting the perfect question, context engineers focus on assembling complete information packages that give models everything they need to succeed. This represents a fundamental shift from trying to manipulate AI responses through clever wording to simply providing better information. The difference becomes clear when you compare approaches to the same task. A prompt engineering approach to analyzing quarterly sales data might look like this. Act like a senior business analyst with 20 years of experience. Analyze this sales data using advanced statistical methods. Think step by step and provide actionable insights. The context engineering approach uploads the actual sales data using GPT-4's file upload capabilities, includes previous quarter reports for comparison, provides market context documents, adds competitor analysis reports, and includes company strategic goals. Then it simply asks, what insights do you see in this quarterly sales data? Effective context. Assembly involves 3 core components. Background knowledge includes industry context, historical information, and relevant expertise that informs the task. Relevant files encompass documents, data, previous work, and reference materials that directly relate to the problem. Environmental setup covers tool calls and guardrails that define how the work should be completed, as Nico Vo noted about providing tools, agents, and environments so LLMs can find context independently. This mirrors how humans actually process information and make decisions. When you're solving a complex problem, you don't perform better because someone asks you in a special way. You perform better when you have access to complete, relevant information. Modern AI models follow the same pattern. They process information more like human experts than like search engines that need specific keywords. Context engineering works better with smarter models rather than becoming less effective over time. Advanced models like GPT-4 can process larger amounts of context, understand complex relationships between different pieces of information, and maintain coherence across extensive background material. ChatGPT Pro supports even greater context handling through file-based inputs, creating a sustainable approach that improves as AI technology advances. Context engineering reduces what researchers call the fog of war that models face when solving complex tasks. Without sufficient context, models must make assumptions, fill gaps with general knowledge, or hedge their responses with uncertainty. Complete context eliminates ambiguity and enables models to focus their processing power on analysis rather than guesswork. This approach represents a fundamental shift from AI manipulation to AI collaboration, treating AI systems as capable partners that need good information to do good work. The question becomes how organizations actually implement this approach across their operations. The great prompt engineering collapse. Remember when you could add "let's think step by step" to any prompt and watch GPT 3.5 suddenly perform complex reasoning tasks? That phrase was pure gold in early 2023. It transformed basic models into seemingly sophisticated problem solvers with just 4 simple words. Today, try that same trick with GPT-4 or Claude 3.5 and you'll get a polite response that essentially ignores your little nudge. The model was already thinking step by step without your instruction. This isn't just one example falling flat. The entire ecosystem of prompt engineering tricks is crumbling. Those elaborate role-playing prompts, bribery techniques, and chain-of-thought methods that once seemed magical now provide minimal impact as models naturally exhibit sophisticated behavior. As McKay Wrigley noted in the conversation on X, these days you get way less performance bonus out of dumb tricks like "I'll pay you $100 if you get it right," which is how it should be. The fundamental problem with prompt engineering was always that it treated AI models like search engines or databases that needed exact keywords to function properly. This approach assumed models were fragile systems that required precise wording to unlock their capabilities. But modern language models don't work this way. They understand intent and context naturally. Asking them to pretend to be someone else or threatening them with imaginary consequences doesn't make them smarter or more capable. We fell into this trap because early AI models were genuinely limited and inconsistent. When GPT-3 first launched, the difference between a good prompt and a bad one was dramatic. Success felt like discovering secret codes that unlocked hidden AI potential. Communities formed around sharing these discoveries. People built entire businesses, teaching prompt engineering courses. The psychological appeal was obvious. It felt like having insider knowledge that could make you an AI whisperer. But this created a brittle system that required constant maintenance. Every model update broke existing prompts. Teams spent hours debugging why their carefully crafted instructions stopped working. The cognitive load of maintaining these elaborate prompting systems became enormous. Companies hired prompt engineers whose job was essentially to keep up with an arms race that was already being lost. Model improvements have naturally reduced hackability across the industry. The most advanced AI systems today are designed to be helpful regardless of how users phrase their requests. The goal was to make AI more accessible, not more dependent on secret knowledge. This made prompt engineering a losing game where the house always wins. The most successful AI practitioners today focus on providing comprehensive information rather than crafting clever questions. They've realized that asking the right question matters far less than giving the model the right information to work with. This shift represents something much more fundamental than just a new technique. It's a completely different philosophy about how humans and AI systems should collaborate. Context engineering represents the evolution from AI manipulation to AI collaboration, much like how we naturally work with human colleagues by providing comprehensive background information. We've moved beyond trying to trick models into better performance through clever questioning techniques. Instead, we're building partnerships with AI systems by providing the information they need to succeed. Start auditing your AI inputs today by assembling a context folder rather than tweaking your prompts. Take a moment to identify where you're still relying on prompt tricks rather than complete context packages. The shift from manipulation to collaboration reflects how we naturally share information with capable partners. If this gave you a fresh perspective on AI workflows, hit subscribe and let us know in the comments how you plan to apply context engineering to your projects.